Besides the life cycle of a widget and the state of a widget, the overall app also has a life cycle. It has a couple of different life cycle states. And of course, the important question then always is, when is this state reached? When can you execute code based on that state? For example, you have the inactive state. Inactive means that your app is not even running in background. It's inactive. The user can't see it. It can't receive user input. It's not fully cleared from memory yet, but it's definitely not, well, too active. A state that can be reached on both operating systems is paused, however. This is when the app is not visible and when it's running in background. So when you can reach it through the task manager of your application, for example. This is available on both Android and iOS, and you can react to the app transitioning into that mode in your code. For example, to do some last-minute cleanup, clear some connection to a server, or anything like that. Now, of course, since you have paused, you also have resumed. This state is reached when your app is coming back from the background mode, if it's again visible and again responding to user input. And this is also available both on Android and iOS. So this would be a good place to then again set up a live connection to a server, check whether you want to change something in your app, fetch new data, anything like that. And there also is a suspending state, which is reached when the app is about to be suspended. So when it's almost gone, but still there, but when it's about to be cleared by the operating system and when it's about to be removed from memory. Now, for all these states, it's important that you never have a 100% guarantee that your listeners to these states are executed, especially for suspending and so on. For example, if battery suddenly goes off or a user removes the battery from the phone, then your app might not reach that state because it's not a clean exit as initialized by the operating system, but a hard exit due to some external factor. That's something to keep in mind. Now, in most cases, however, you can listen to these life cycles, and therefore let's do just that. So how can we listen to these app lifecycle events? Let's do it here in the main Dart file on our My Homepage state. There, you can add a so-called mix-in. We haven't used it before. It's basically, it's a bit like a class, and it's a bit like extending a class, but your class is now not based on that class, but it adds a certain feature from that class you're mixing into your class. So you're adding certain properties, certain methods this other class has, without fully inheriting this other class. It has some technical differences. You also only can inherit from one class. So if you want to bring in features from multiple classes, you would use a mix-in. You use a mix-in by adding the with keyword after your class and after all your extensions, or the one class you're extending from possibly, and then the name of the class you want to extend. And here, that's the widgets binding observer class. Widgets binding observer is something you import here or you add here as a mix-in, and once you did that, you can add a new method, maybe here after our properties. The new method you can add now is did change app lifecycle state. That actually is a method added by the mix-in, and therefore we add override here to make clear that we deliberately override this. You return nothing here, hence you have to add void. And this method receives an argument of type app lifecycle state, which you can give any name you want. And this is the state the app now transitioned to. So this method will be called whenever your lifecycle state changes, whenever the app reaches a new state in lifecycle. Now, here already important, and hence you should always add this mix-in on a state object, on a class extending state. You also want to clear that listener to lifecycle changes when that widget, when that state object is not required anymore. So let's add dispose here with add override, and in there call super dispose and clear listeners to lifecycle changes. Otherwise, you keep that listener up and running even if that state class, that state object should be deleted. Of course, here for our main state that can't happen because when that gets removed, the entire app is shut down. But if you have a bigger app and you add your app lifecycle listeners in just one child widget somewhere down the widget tree of your app, because in that child widget you're interested in changes to the lifecycle of the app. Well, then when that child widget gets removed, you certainly also want to clear your lifecycle listeners to avoid memory leaks. So here in this pose, you clear all listeners you have to the app lifecycle by referring to widgets binding, and then there the instance property, and there you call remove observer this. Now, before you can remove it, however, you also need to set up a listener. So for this method to be triggered, you need to add a listener, and you do this by adding init state. And there you now use widgets binding instance add observer this. So with this line, you're saying, or you're telling Flutter, hey, whenever my lifecycle state changes, I want you to go to a certain observer and call the didChange app lifecycle state method. That's what widgets binding tells Flutter. We then tell Flutter that the observer is this, so this class itself, and therefore this class, of course, needs to have a didChange app lifecycle state. With that now available, this will get triggered whenever the app lifecycle changes, and as explained, we have to clear our listener, we have to clear our observer here to avoid memory leaks when this state object should be removed. And now in this method here, didChange app lifecycle state, you can react to changes in your app lifecycle. And for now, I'll simply print state here so that we can see what the new state is. For that, let's restart the app. Let's maybe even do a full rebuild here. So close the running emulator and restart without debugging so that this gets rebuilt and launched on the emulator or on the real device. And let's see what's happening there, which logs we see. The app restarted, and if we go back to the debug console now, we see no lifecycle states here, right? We see just the build methods running, constructors running, and so on. We see no lifecycle app lifecycle methods here. Well, that will change if we go back and we press that home screen button here on Android. So we're back on the home screen, but our app is still running. We could access it here through the task manager. Now what you see is that here we entered inactive. So this was briefly entered on Android, but then immediately after that we actually enter paused. So it first gets inactive, but then Android kind of detects, hey, this is actually just paused. It's running in background. And now if I open the task manager and I go back into this application, we see that here is where we were. It briefly goes back into inactive. So basically during this switch, it goes into inactive, but then it enters resumed because now it's getting back from paused to running again. Now, if I kill the app now, by swiping up here in the task manager, we see it enters inactive and paused, and what we don't see here is suspended. So this is not getting printed here. In theory, suspended should be reached here, but since we clear the app here, also the connection, the debugging connection here, is cleared, and hence the suspended state, whilst reached, might not make it into our console here because we already cleared our listener here to our app. So this all happens in a very short amount of time, and therefore suspended should run. As I mentioned on the slide, you can't always rely on it, but it should run. But here, for example, we don't get our log being printed because we already cleared the connection, the debugging connection to that app, basically at the same point of time suspended would run. But we can clearly see inactive and paused and resumed, which are the most important lifecycle hooks, because you would use that to, as I said, for example, refetch data when it's coming back into foreground or to clear listeners when the app is getting paused.